All right, so the next poster is going to be on predicting baseball performance, and you guys can take it away whenever you're ready.
All righty. Good afternoon, Data Plus participants, viewers, family members, and all extended parties. This is Predicting Baseball Performance. My name is Malik Scott, and along with my colleagues Jessica Ho, Jack Lichtenstein, Amber Potter, Foot Nagayan, Zone Liu, Greg Applebaum, Tim Sell, and Mark Richard, we will be presenting our work from this summer, which would not have been made possible without USA Baseball Roads Information Initiative and Data Plus. So thank you to all those entities. And with that, we'll start with a general overview of the project. So USA Baseball is an entity that selects the most elite baseball players in the United States from middle school, high school, and college, brings them to different summer camps and summer leagues, does visual, oculomotor, and athletic assessments.
I think he's gonna end up in sports medicine.
And then tracks them.
He says he wants to do
after their completion of the
epidemiology.
Sorry, Malik, I was muting people to try to get rid of the feedback, but I think I accidentally muted you. Sorry about that.
It's all right. But yeah, thank you for that, by the way, Greg. But yes, just to continue, after completing all of these assessments on the players, they then send them out to complete their normal baseball seasons and then continues to track them through their prospect development pipeline. So using RIDE-Eye technologies, TrackMan technologies, and of course collecting their statistics from the NCAA, they're able to then compile a bunch of data from their statistics as well as their assessments. And then what they did was, after collecting this 2018 and 2019 data, they looked to us, Team 18, Predicting Baseball Performance, to see if the variables from their assessments at the camps actually had any predictive power towards how these players performed in their games. And so as a second objective, they also asked us to develop an application to be used as a visualization tool that they could then use for visualizing all the data that they are collecting. So what we're going to do in this poster is we're going to tell you all about the different assessments that were collected as part of the PDP pipeline, explain how we cleaned up the data and imputed, and then how we analyzed these relationships and completed our later powerful hierarchical regression models. Then we'll end with a description of our Shiny app that we developed for visualization. So from here, my colleague Jessica will take it away with measuring vision and athleticism.
Thanks, Malik. So each prospect that comes into the player development pipeline goes through a battery of assessments that we call the PDP assessments. And they go through a battery of vision assessments using the right eye tracking system, which we call the right eye assessments. In addition, we have game stats that are either coming from the camps or from the college and summer games. PDP assessments are a variety of 8 different tests that measure athletic ability, agility, and some cognition. For example, the first picture below is a 30-yard sprint test assessing physical ability, whereas the second picture represents an agility and cognition task. The right eye assessments are 10 different tests that implement eye tracking to measure the quality of their eye movements. So the third picture is an example of the smooth pursuit assessment. This is the data we were given. The next step was to evaluate the quality of the data for normalcy, multicollinearity, and sensibility, and then we cleaned it up. After imputing missing data, we found good adherence with differences in athletic abilities when comparing across different school classifications, such as middle school, high school, and college. We also noticed differences in right eye data from year to year, which may be attributed to different testing arrangements. Where we found these differences, we were sure to include these as control variables in our subsequent hierarchical models. My colleague Jack will take you through measuring batting performance.
Yeah, thank you. So one of the most interesting data sets that we were given is taken from TrackMan Doppler radar, which is able to track the baseball and give us pitch by pitch level data. So it gives us all this great stuff like how fast the ball was traveling through the strike zone, where it landed in the strike zone, how much was the vertical break and the horizontal break, and all that really interesting stuff. So if we want to measure batting performance, we want to really try to isolate the pitcher batter competition. And so in order to do that, first we have to define a strike zone, because we know that calls from umpires are going to be inconsistent because they're only human. So we use the combination of signal detection theory, trying to differentiate the variability between the signal, which is strikes, and the noise, balls, and also just experimenting with different strike zone sizes to come up with one that most accurately defined how the umpires called strikes. And then we also want to try to measure these players' plate discipline. And so one of the ways we could do that is looking at their contact percentage, which is conditioned on them swinging, how often do they make contact, O-swing percentage, which is conditioned on the pitch being a ball or a bad pitch. Do they swing? You don't want to do that. You want to have a low O-swing. Or Z-swing, which is the opposite, conditioned on it being a strike. How much do you swing? You want high Z-swing percentage. And so what we can do is, instead of looking at that in terms of the aggregate data, instead of counting up all of these pitches, we can take all this great variables and differences in these pitch by pitch level data and fit models. So we use GAM models to predict the propensity scores for each of these plate discipline and coordination metrics. And so that gives us more robust estimates of these players' abilities, because you can imagine that some players might face really difficult pitches and some players might face really easy pitches. And so modeling this and accounting for all the release speed and stuff like that gives us a better estimate for these players' abilities. And so in addition to that, we also have another subset of players that have their college, Division I, NCAA, and summer league statistics. And those are more familiar to many baseball fans, like average and on-base percentage and strikeout and walk rates. So what we end up with is we have two subsets of players. One subset is the players with college stats from NCAA, and another subset we have data from the TrackMan radar, which is another 98 players. And so going forward, what Amber will tell us in her modeling section is we have two separate data sets in which we're going to model with, one for the players with the college stats and another with the TrackMan radar.
Yeah, so for our modeling, we chose to use hierarchical linear regressions, like Jessica said, or like Malik said, sorry, for each of the outcome variables, with the outcome variables being batting average, on-base plus slugging, weighted on-base percentage, strikeout rate, and walk rate from the TrackMan data set, and Z and O swing propensities, contact percentage, average launch angle, distance, and hit velocity from the college stats data set. For each of these models, we started with our null model, and then we added our baseline demographic variables, and eventually we added other predictors from PDP and right-eye to try to improve the predictive power. Generally, the models that included the PDP or the right-eye variables were far less significant, and our best models were generally only included our demographic variables. Also, I just wanted to briefly mention that we fit some regularized ridge and lasso regressions for each of the same variables, but our results were just as insignificant. And then going on to our observations and the discussions surrounding our results, we can generally say that the demographic variables predicted batting performance, while the assessment variables did not. By putting this in the context of our existing baseball knowledge, it makes sense to us that these player demographics, especially position and body type, would correlate with various batting outcomes. But the lack of significance from the player assessments might have been because of the various limitations that we faced, especially with the extent of the data that we received. And then we're interested in exploring the limitations with more data, like repeating and doing these models again, especially including more pitches faced per player from additional TrackMan data. And we're also interested in doing cross-sectional and longitudinal analysis and adding it to our app, which Jack will now talk about.
Yeah, so although we didn't get the most predictive power from these baseline vision and athletic assessments, we're still able to produce something very valuable to the people at USA Baseball and the prospect development pipeline who've been helping us this whole time. And it's in the form of Shiny application, which I will start sharing right now here. Hopefully everyone can see this. And so this is sort of a tool for the scouting community and the people at USA Baseball. And so what you can do is they upload a file that works in their workflow, and they can filter for different events they have, different players, the grade level, their positions, and then they can plot things. And they have all these different variables that they're interested in, like height, weight. These are jumping abilities. These are single leg jumping, and there's speed, stuff like that. And so what they can do is they can download this file, and they get a nice plot here, and you can see the percentile ranks of these players, whoever they want, to see where they stack up in comparison with their peers. And so this is just a great tool for the scouting community in general. Here's college batting performance. You can plot this player. He had a 20th percentile on the strikeout rate, which is not great. But so yeah, that's just an example of the Shiny app, and we'll open up to any questions.
Thanks a lot. The app looks really nice. Are there any questions that people have in the chat, or do they want to make any comments or anything?
And I can go back to the poster if necessary.
So one of the things that Amber, that you had mentioned was, talking about the heights of the players, the stances that they're taking, all of this stuff that goes into. So I know that mostly you're talking about like vision and reaction time and things along these lines, but I wonder what would be the hurdles towards expanding your analysis to say something like, okay, given that I'm this height, how should I stand at the plate in order to sort of make, thinking about, there's a couple things I could think about. One, I could think about how would I stand at the height to maximize the noise of what the strike zone would be. If I stand in one way, there may be a lot more variability in terms of what umpires call strikes and balls, versus if I stand in another way, that may reduce the noise. Or I may be able to shrink the strike zone if I stand in certain ways as well. So I'm just wondering how amenable to expanding your analysis to something like that would be, because that's not less of a vision problem and more of an interpretation problem from the umpire. And then I guess, sorry, just one follow-up is to what extent does that confound, could that confound your current interpretation of how vision is leading to sort of perception of what is a good throw and what's a strike that I should play discipline, essentially?
So as far as height kind of affected a lot of the batting performance outcome variables that we use, the taller players, just like the heavier players, typically had a lot more power. So their batting, like average, or their slugging percentages were typically higher. But then taking this on the second part of your question, how it affected the strike zone, I think earlier in the summer we explored how taller players, their strike zone included more outside pitch called strikes by the umpires. And like that's just something that we found that wasn't really the same for shorter players, or even it affected right-handed batters more than left-handed batters, which was just like a small detail that we ended up not including in our final models. But there are so many like tricks that I know that baseball players or even softball players use, as far as like where they wear their like pant length, as far as like drawing attention to their knees being higher. Because I know a lot of tall players, like Aaron Judge, for example, has like complained about getting called on a lot of low strikes. And it's kind of like a common thing where taller players will wear their pants at their knee, or even like there have been a couple major league players who've worn their pants like above their knee, just kind of like using like the contrast between the pants and the socks to draw attention, catch the umpire's attention. So I think if we were able to like possibly continue this, or even like next summer or into the next fall semester, it might be interesting to kind of take a larger sample of the data, the TrackMan data that we got, kind of plotting like the bottom edge of the strike zone and seeing how this correlates with a lot of their performance.
Yeah, that makes sense. Thanks. And so, and then I guess so. The follow up was, to what extent does does this stuff? Because I mean, so one of the things you had talked about was plate discipline, right? Which is, how, which is my understanding of it is how likely are you to swing on a strike and not swing on a ball, right? So do you take that into it? Do you take these sort of, as a player as a player's body or position changes, do you take that into account with, okay, well, it's harder to have strike discipline because there's less certainty with what's going to be a ball and a strike, or is this just sort of a one size fits all strike zone?
Yeah, so we ended up with a one size fits all strike zone. So I don't think we have enough data to try to define these strike zones for individual players. You're probably going to just end up overfitting to the small number of pitches that these players saw. So like one of the big limitations for us was just the amount of data that we had with the TrackMan stuff in particular. We only ended up with 98 players, and we filtered for 40 pitches faced. So we're trying to evaluate these players on such a small number of pitches, which is really just not a lot. I think the most number of at-bats that a player in the TrackMan dataset had was 49, which, if you notice, wouldn't even make our cutoff for the college stats. Like, I'm sure that, the MLB and maybe college teams that have just a huge boatload of data from these radar cameras, they can get a better understanding of how the strike zone changes based on height. And I think if we were to do that, we would just end up overfitting and probably artificially inflating or deflating some kids' abilities.
No, that makes a lot of
Just gonna
sense. Thanks.
add to that real quick. Very recently, we received a much larger data set from, or like a larger subset of the TrackMan data set. And I think it'd be more feasible for us to explore a more dynamic strike zone with a larger data set.
No.
Yeah, and let me chime in here. What a great job the team did on this project. It's real world data that came in from USA Baseball. USA Baseball measures the heck out of a lot of people, and we were able to get a data set that combines a bunch of the assessments and the outcome variables that was pretty narrow in terms of the number of observations we have for each person. The college stats had more observations, but less acute, meaning things that go into these counting statistics don't just depend on the pitcher and hitter. They depend on the fielder, they depend on the context. In the TrackMan data set, we had what's really good granular data on the decision-making of each person, which is what we're trying to predict with these assessment variables, but a fairly limited amount of data because it only gets compiled from the camps that these players are at, which might be like a weekend camp or something rather than a whole season. So I think the team did a fantastic job of trust but verify, go through, look at the data very carefully, find places where We thought we needed to include some control variables, things that weren't necessarily expected, building out the models. And unfortunately, given this subset of data, we didn't see relationships, which we would have loved to see. But we built a nice framework for doing these analyses. And as Amber mentioned, now we're in a position, and I think we'll try to continue this project going forward in a collaboration with USA Baseball, where we have thousands of separate individuals with the assessments, and hopefully we'll be able to match that with bigger data on their outcomes. So maybe possibly getting their TrackMan data from the college seasons, or conversely, doing analyses that aren't necessarily predictive analyses, but are either longitudinal or cross-sectional analyses. So, it's a little bittersweet not coming up with some like, oh my gosh, if you do well on this test in the camp, you're going to be an all-star baseball player. But I guess that's why scouting is such a challenging enterprise. If it was as simple as, scoring well on one test, they would always scout and draft exactly the right players, but it's not as simple as that. So the team did a good job of analyzing the real world data and also building some utility for USA Baseball by creating this app, which now makes it possible for them to grok big data very simply with these nice visualizations.
Yeah, absolutely. And I actually I did have a question about the app you did, the dashboard you put together as well. Which, I mean, it looks great, and it's almost a little bit scary to me in some ways, because it almost looks like it's like shopping for a car or something. Like you pick the number, and then you're like, oh well, it has these performances. One of the, I mean, so of course there's the scary part of the almost dehumanization part of it, but then there's also the I think with what the data that we decide to present can definitely skew our perceptions. And I'm wondering what weaknesses, or do you think that there may be any weaknesses in the dashboard you have of focusing on certain things with de-emphasizing other things that may be important? Or, what biases are you maybe worried about introducing with the data that you're presenting on the dashboard?
Well, so first, the for Data Plus, we have to make them like player one, player two.
Of course,
we can't see them. So for PDP and the USA Baseball, they can see the names.
I see.
So it's maybe less dehumanizing. but in terms of like the biases, I'm not too sure. I think like I'm not a part of the data collection. So yeah, I'm not. So one of the things that we came across was some players come in like as 8th graders and take a test with PDP, and then they come in as 10th graders and take it again. So how do you deal with like players taking these tests multiple times? And so for our modeling, we decided to take everyone's first assessment because we were afraid of learning. Kids might, get better at certain drills if they just do it more than once. But so for like this dashboard, you're able to filter for first assessments or last assessments or all of the assessments. And so for looking at these players, it's useful for them to look at the most recent tests they have, but you also can look at all the tests and then view one player over time. So say they have 3 tests, and then you look at all 3 sequentially and see how they improved.
And I would just say those biases that are possibly there are baked into what USA Baseball tests these guys on. We just get the data at the end, but USA Baseball, and Drew is on the call here. He's one of our colleagues with USA Baseball, but they're testing them on the 30-yard dash and not their squats or bench press. Whereas the NFL Combine, they test them on squats and bench press. So that's kind of the mission that we were after, was like, do these things that they're testing them on really correlate? They think they do. They came up, they're not accidents that they're measured on these assessments, but to some degree for us and for this Shiny app, any biases are baked in by what USA Baseball is deciding to test players on. Drew, did you want to chime in?
Sure. Some of these assessments here, PDP is in partnership with MLB as well. So there's kind of some unwritten rules and fine lines that we can't really cross. So what we've come up with here is, the best options to test these athletes' capabilities, physically and then cognitively. So we would love to do, a functional movement screen. We would love to get their squats and bench press and all that kind of stuff, but we are not capable of doing that at the moment because, MLB wants what MLB wants. So we kind of got to live within those guidelines and work with what we got. But working with these guys through this has been an awesome experience, and this app is incredible for our uses. So we've been messing around with it the past couple weeks and going through it, and even we just finished up an event yesterday with our 17U athletes, and ran that event data through there, and this thing worked like a charm to compare some athletes. So it was really awesome to use it real world immediately after they created it. So it's been awesome.
Yeah. No, I think that's a really good point in terms of we kind of get it in our heads about what we think the important data is, and then we just live with those consequences. So I appreciate that a lot. Thanks a lot. This was a great presentation, and it's really interesting and really cool what you guys have put together. So we can give a virtual round of applause, and yeah. We'll take about a 5-minute break until the next group goes.